Hello everyone, here we are back again with a new topic, that is quick return mechanism. So first of all, what is quick return mechanism? We'll just have a brief look what is a quick return mechanism. Okay, so a quick return mechanism is a system to produce a reciprocating effect such that time taken by system in return stroke is less time taken by it in the forward stroke. In quick return mechanism, a circular motion is converted into reciprocating motion, just like crank and lever mechanism, but it has return stroke time is different but from forward stroke. So the main reason is that it has return stroke time different from forward stroke. Okay, so this mechanism is used in many machines. Some of them are mainly in shaper machines in the workshops that we have seen, slaughter machines, okay, screw press, mechanical actuator, etc. Okay, so with the help of quick return mechanism, the time needed to cutting is minimized. The main objective is to minimize the time taken for cutting the material. Okay, so for quick return mechanism, the best example you can have a look on the shaper machine, because you have already gone through it in the workshop. Okay, so there are various types of quick return mechanism. Number one is the hydraulic drive. Okay, so hydraulic drive mechanism is one of the mechanisms used in shaper machine. So in this mechanism, the ram is moved forward and backward by a piston moving in a cylinder placed under the ram. So referring to the diagram here, you can see this is the ram. Okay, so this is the cylinder, this is the piston, and here is the piston rod. Here you can see the arrow marks here in the figure. So it is the piston rod, piston here, cylinder here, and this whole thing is the ram. Okay, so here what happens, the machine is consist of constant discharge oil pump, a cylinder, a valve chamber, and a piston. Here you can see valves, then valve chamber, then relief valve, oil reservoir here. Okay, so oil pump here, okay, etc., and the tool is attached here. Okay, so the piston ram is bolted to the ram body. Piston rod is bolted to the ram body. Okay, so hydraulic fluid is used in hydraulic quick return mechanism for the movement of this ram. This ram will move forward as well as backward. Okay, to and fro. So here is the working of hydraulic drive, how it works. So in hydraulic drive, there is a tank at the bottom which contains the hydraulic fluid. This tank is also known as oil reservoir here. At first, the oil from the reservoir, this oil is passed through the valve chamber present in the right of the oil cylinder, exerting pressure on the piston. Any oil present in the left side of the piston is discharged to the reservoir through the throttle valve. At first, the fluid in the tank is pumped out, and this fluid passes through the passes present in the right side of the cylinder. This fluid exerts pressure on the piston, and the ram of the machine performs forward stroke. Okay, so when the ram moves forward, the lever changes its position and hits the reversing down. So as the lever changes its position, the three valves connected to the lever also change their position, and now the oil can pass through the passes present in the left side of the cylinder. Here you can see the arrow marks here, this arrow marks. Okay, so this is the inline marks from this oil tank or oil reservoir. The oil moves in this direction through the arrow marks, goes to the ram inside the cylinder, then piston, and again it comes back through this line to the through the throttle valve. It comes again to the oil reservoir, and this process continues. Okay, so after the forward stroke is completed, the valves changes its position, and now the pump fluid from the reservoir moves from the passes present in the left side of the piston. Also, the passes through which the oil return to the reservoir opens and get connected to the right passes, and the fluid present on the right side of the piston is discharged to the reservoir. So as the fluid moves towards the left side of the piston which is attached to the ram moves towards right, and return stroke is performed by the ram. Okay, so at the end of the return stroke, another dog hit against the lever, and the direction of the lever as well as the stroke changes. So in this way, the forward and the return stroke of the ram is repeated. The quick return takes place due to the difference in the stroke volume of cylinder at both ends. Okay, so the volume of passes at the left side is less than the volume of the passes on the right side. So as the pump is constant discharge pump, same amount of oil will be passed on the both passes. So the pressure and the passes with less volume will be more, and the return stroke will be faster than the forward stroke. The cutting speed can be controlled by controlling the flow of oil, which can be controlled by using the throttle valve. So when the throttle valve is lost, the excess valve is cut through the relief valve as shown in the figure that we have already gone through to the reservoir, maintaining uniform pressure during the cutting stroke. Okay, so next we move on to Whitworth quick return mechanism. So in this mechanism, what happens? This mechanism changes the rotary motion to oscillatory motion like the crank and lever mechanism. So the difference between the crank and lever mechanism and Whitworth mechanism is that in Whitworth mechanism, the return stroke is faster than the forward stroke, while in the crank and lever mechanism, the forward stroke is of same speed as that of return stroke. Okay, so here are the parts of Whitworth mechanism. Number 1 slotted bar, number 2 slider, number 3 crank. It will rotate. So here you can see in the diagram the Whitworth quick return mechanism. Here it is fixed point A. So this way it is the cutting stroke. In this way it is the return stroke. This is the connecting rod. This is the connecting rod. Here you can see the line of stroke. The tool is attached with the ram. Okay, so in this here it is the slaughter. This is the slotted lever. Okay, so slider, this is the link 1, which is the slider. Link 2, here it is this one is the link 2, which is the crank. Okay, so this will rotate in this direction, the rotary motion, and with that there is oscillatory motion will takes in the place. Okay, with the help of this slaughter. Okay, so let us go to the explanation part of this Whitworth quick return mechanism. So Whitworth quick return mechanism is the second inversion of slider crank mechanism, in which the crank is fixed here. Okay, so in this mechanism, the slider in slotted bar is connected to the crank. So when the crank rotates, the slider will slide inside the slotted bar and the slotted bar will oscillate. So as the slotted bar oscillates, the ram will move in forward as well as in backward direction. So the return stroke or ideal is faster than the forward stroke in this mechanism. In the above figure, AP is the slotted bar and link 1. CD is link 2. AC, which is crank, is link 3, and link 4 is the slider. Here if you refer to this figure, you will find out. Okay, in this mechanism, the link CD, that is link 2, forming the turning pair, is fixed as shown in the figure. The crank AC revolves with uniform velocity with its center at A. A sliding block attached to the crank pin at B slides along the slotted bar AP and thus causes AP to oscillate about the pivoted point A. A short link PR transmits the motion from AP to the ram, which carries the tool, and thus forward stroke and backward stroke is obtained. The crank needs to rotate through an angle of beta for the forward stroke. Here you can see the angle beta, okay, for the forward stroke, and it needs to rotate through an angle alpha for backward stroke. Okay, sorry, yeah, this is the angle alpha. Okay, so as the crank moves with uniform angular velocity, time taken to cover angle alpha will be less than the time taken to cover angle beta. Hence, time taken in return stroke will be less than time taken in forward stroke. Here, this is the main. Okay, so in this way, the quick return mechanism works. Next, we move on to crank and slotted link mechanism. Here, In crank and slotted link mechanism, the power is transmitted to the bull gear. Okay, so this is the bull gear. Okay, so this is the bull gear by a pinion which receives its power from an individual motor. In a two-gear system, the smaller gear is called pinion and the larger gear is called bull gear. Okay, so here you can see in this figure this ram, screw shaft, crank, bevel gear, driving pinion, this rocker and pivot, then sliding block, crank pin, slotted link, ram block, bevel gear, everything is given in this figure clearly. Okay, so here is how the crank and slotted link mechanism works. This radial slide is bolted to the center of the bull gear. This radial slide carries a sliding block into which the crank pin is fitted. As the bull gear will rotate, the crank will revolve at uniform speed. The sliding block, which is mounted upon the crank pin, is fitted upon the crank pin is fitted with the slotted link. This slotted link is pivoted upon at its bottom end, attached to the frame of column. The upper end of the sliding link is bifurcated and attached to the ram block by a pin. So when the bull gear rotates, the crank pin revolves at a uniform speed. The sliding block fastened to the crank pin will rotate on the crank pin circle, and at the same time this slider will slide up and down in the sliding link. So as the slider will move inside the sliding link, it will provide a rocking movement to the sliding link, and this movement will be transferred to the ram, providing it a reciprocatory motion. So hence the rotary motion of the bull gear is converted into reciprocatory motion of ram. Okay, so this is how the working principle of the crank and slotted link mechanism takes place. Okay, so with this we have come to the end of this lecture. Thank you everyone.